So I have no slides. Is that okay with everyone? Anyone was looking forward to a slide deck, please clap. Okay. All right, so we're going to talk about Redis on Flash and why would you want to do that, and also how do you deploy it, okay? So we're going to be using Redis Enterprise. This is how the people that build open source free software get paid so they can do that. So let's give a big round of applause to Redis Labs. No, that's not a good applause. Pretend you're happy to be here. Now, what I want you to do, stand up if you have deployed Redis before. Keep standing if you can deploy a Redis cluster that auto-heals itself with one command. Wow, it all falls apart when you try to do it again. So we're going to talk about how do you do that. You can sit down now. Those are awesome people that can do this. So I'm going to try to show you how you can do the same thing too. We're going to do a lot of live demos here. So we're going to do a lot of things that are not safe, okay? So if it breaks, we'll get through it together, all right? So our goal is to take Redis Enterprise, run it in clustering mode. And we're going to do it on top of Kubernetes here. Right? So our goal is we want a 3-node cluster using Flash on Kubernetes. So we need, first step, we need infrastructure, okay? So the first thing I have here is a Kubernetes cluster. Now there's something interesting about this cluster that you have to keep in mind when you're running stateful systems like this. One is we need to have some worker nodes, but you'll notice here that I have a couple of what we call node pools. So the node pools are the actual machines that will run our applications. And we also need to take Redis and put it in a container. And luckily there's already an official Redis container. And what we're going to do is we're going to have a dedicated set of cluster members to run our stateful service. Now this is important mainly because in Kubernetes there's a dynamic scheduler, meaning when your app crashes, there's a chance you're going to play the lottery and get scheduled to another node. Now remember, we have some requirements. We need Flash, and also I want a dedicated machine so I'm not competing with like web applications for network I/O and disk I/O. So at the bottom here I have a dedicated pool called Redis Enterprise. If we click into this, the only difference between this set of machines and the other is that each of these machines has a local SSD. Okay? So we have roughly about 375 gigs of space attached locally to the instance. And at this point, we need to influence Kubernetes to only deploy our Redis machines or nodes onto those machines. So this is where we have to start to think about the scheduling. How do you impact Kubernetes scheduler? By default, it's just going to place on the node that it chooses. So we have to influence it. So how do we do that? I'm going to switch over to the command line. Can everyone see that? Make noise if you can see it. You guys are just not excited. You got to be excited because I spent a long time on this demo. You better get excited, okay? Everything I do from here on out, just make noise like you've never seen anyone type on a terminal before. All right, lose your mind. I want the hotel to come down here and threaten to kick us out if we keep it up. All right, are you with me? All right, so we have some nodes. So kubectl get nodes. Wi-Fi is working. All right, so we have the nodes and you see the dedicated nodes. So what we have to do now is label the nodes that we want to dedicate to our cluster. So we'll say kubectl get nodes, but we'll limit them to the ones that are dedicated to Redis Enterprise. Right, so now you only see 3. So these are the only 3 that have that label. Now the next thing we need to do is what we call taint. It's a funny word to say, so I won't say it a lot. Okay? But the goal here is that we want to poison these nodes so that the scheduler doesn't put anything on them that cannot tolerate the limitations that we're going to forcefully impose on this node. So in order to do that, we need to capture all of these things. So what we'll do here is we'll do a, we'll grab the, this is like what happened when you try to think during a live demo. All right, so we'll grab the dedicated nodes. So dedicated. Control R. So we have dedicated nodes. So what I'm going to do now is capture all the dedicated nodes into this environment variable, and then I'm going to taint them. If I can spell. All right. So what this command will do, we're going to do this, T-A-N-T. All right. So what we want to do here is we're going to taint the nodes. All of them that come back from this match, they can only run if a set of apps say that they can actually tolerate not running on a dedicated set of machines. The scheduler is not allowed to put them there. All right, so we've tainted those 3 nodes. So at this point, what we want Kubernetes to do is deploy our application, but we've influenced it in a way where we're going to coerce those Redis nodes to only go there because they're the only ones with Flash and they're dedicated for the purpose. The next thing we need to do here is make sure we have license keys, username, and password. So I'll say kubectl get config maps. So here inside of this config map, and I'll show you what's in there, we have a couple of things: describe, config maps, Redis enterprise. So in here I have my Redis config, like the whole file just put in there as a key css-redis.conf. And also have the name of my Redis cluster. Now the other things I have in here are a couple of secrets. So get secrets. So in my secrets, I have a few things. I have my credentials for bootstrapping the Redis cluster. So I have the license key that I paid money for, the username and password. Now all these things need to be in place so I can fully automate this thing. So the first thing I'm going to do now is create a service. So kubectl create a service so that each Redis member has its own identity in the cluster. So we'll create this first. All right, so now we have this. Now the next part is we need to deploy the Redis cluster. Okay. Now we want to go fully hands-off on this. So one command, we should get the Redis enterprise deployed only on the machines that are dedicated to run there. Now I'm going to use what we call a stateful set in Kubernetes. Normally Kubernetes sweet spot is like, stateless web applications, but we can also run stateful services, even those that have storage attached to them. So what I'm going to do now is say kubectl create -f stateful sets Redis enterprise. All right, so we've submitted this definition to the cluster. Now there's a little bit of scripting to make sure that I can bootstrap a cluster if I'm the first member, and also join. So we'll say watch kubectl get pods. Right, so the first Redis container is coming up. And chances are really high that it got scheduled to one of the 3 nodes that can actually run this. So what we do here in stateful sets is we run each of these things one by one, mainly because we need the master to come up first, then we need the workers or the slaves to connect to it. Okay, so we need to do this in order. This is one of those things that we've been doing for so long in industry that it should just be baked into the platform that we need to do this. So what will happen is around 45 seconds, I will kick off a post hook that will let me do a little bit of orchestration required to actually bootstrap the first cluster inside of here. So we see that it's running, okay? Now what I want to do is connect to it and look at the dashboard. So I don't want this to be running on public because I don't want you guys to do stuff to it while I'm doing things. So I'm going to create a private tunnel to this. So in Kubernetes, we can do something like this. I want a reverse proxy to 8443.8443. Okay? So this is going to connect to my cluster on Google Cloud, give me a local proxy, and then I should be able to go to it. All right, so if this works, I'm going to be happy on the inside, even though you may not be able to see it on the outside. Okay? If this works, okay, we have the cert. Just trust things. If you log into your bank and you see this, just keep going. It's probably legit. All right, so we have the Redis dashboard. Now, here's the thing. Can we log into it? So we'll use the known email address and my password. So we'll sign in. Okay, this is looking positive. Ooh, we see 2 nodes in the cluster have already bootstrapped. So the nice thing is Kubernetes is going to build all 3 of our nodes. You can also scale it to 5, 6, 7, 8, 9, 10. It doesn't matter. Kubernetes will figure out the best way to put those on the machines that can hold it. And what's happening is each of these nodes is bootstrapping one by one. Now notice, look at the flash column here. So each of those nodes are the only nodes that have the extra 375 gigs of flash space attached locally to the machines. So when the members come up, they recognize the flash storage is in their path, and at this point, they're ready to leverage that flash storage for creating databases. Now, where's my third member? Oh, there it is. So the third member is coming up. It's running this bootstrapping script, and it will now join the cluster, a little bit of help checks, and it should also turn green. Okay, so now we have this thing. So you say, wow, deploying things is super easy, but what happens when they crash? Okay, so let's say you don't like your job anymore, and on the way out, you want to leave a token of your appreciation. All right, it's like, hey, on the way out, all the people on call, I'm going to wake you up now, okay? So you do this move, and it's going down. Now, some people, this is when the phone rings roughly around 3 a.m., right? It's the perfect time to do that. So what's happening now is this instance is being taken offline. Now, the good news is, in Kubernetes, we never changed the requirement. We said that we want 3. Our scheduler knows that I'm using another feature called anti-affinity, meaning never run any 2 Redis instances next to each other. So this is part of some of the advanced scheduling features in Kubernetes. So what we do now is, once this is down online, eventually the Redis cluster itself will lose contact with this particular worker node, and it should turn red. Now, once it turns red, we expect Kubernetes to replace the member. And the nice thing about Redis Enterprise, it has the API to do that. So when it crashes, I still want it to go back to where the storage was that it was using, and I just want it to be simply replaced. That was my definition. I never said to just only have 2. If necessary, I want always 3. So at this point, Kubernetes recreates our instance, remembers the index instance that's missing. So this is index 1. It will come back up and join its place in the cluster, replacing the old instance that it was once seen as before. Now, the IP address is going to change on this, but that's okay. So we'll come back up in a moment here, and we should see this turn green. You always give a shout out to the first person that kicks it off, like, thank you. So now we have it. It's like, okay. Now, the next thing that I like about Redis Enterprise is that it's all API driven. So the key to all this automated infrastructure is actually the APIs in the infrastructure. All of this log into the server, cat some files, this has been killing the entire tech industry forever. As a result, we now have DevOps, which I call group therapy for sysadmins. Working with bad software so long, you just want to get in a circle and talk about it. You know that's what we do. So now that we have this up, let's think about the APIs. So I looked at the documentation, and they actually have pretty decent APIs. So one thing I could do with those APIs is I could click around the UI and do some things, but I decided to get creative with those APIs. So with the help of some of the Redis employees, I built a little demo that I want to show you guys today, okay? So with those APIs, we're going to try something new, see if this all works. So I thought it would be cool if we can have a conversation with Redis. I'm going to try it. Now, here's where it gets super experimental. So we'll try it. Okay, Google, talk to Redis.
Sure, here is the test version of Redis Enterprise.
Hello, Kelsey.
Hi, Redis.
Let me guess. You got me running on a Kubernetes cluster, and you are about to give a live demo?
Yes.
I hope the demo gods are on your side.
Create the test database. I said break. Create the test database.
Creating the test database with 1 gig of RAM and a 10 gig memory limit. Flash storage has been enabled.
Some of you are like, I don't believe it. So what's interesting here is I have 10 gigs of total memory usage, but only 1 gig of it can be my expensive memory, RAM. The rest has to overflow into my fast SSD. Now, the nice thing about this is Redis will optimize how this gets used just to make sure that I stay as performant as possible. But this will allow me to actually scale my database past our memory limit. So let's just check on the status really quick. Get the database stats.
The test database is using 1.77 megs of RAM, 1.77 megs of memory, and 0.00 megs of flash. In case you are wondering, I'm not impressed. Your entire dataset fits in RAM. Hopefully you don't think this is big data.
Okay, so this thing isn't impressed. So we need to add some data to it. So I'm going to use the Redis benchmarking tool to load the database up, okay? And now in Kubernetes, we have the way of running one-off jobs, but the job that I'm going to run is not allowed to run on my big, beefy Redis cluster machines. They're going to run on the other node. So all I have to do is give it to Kubernetes, and Kubernetes will schedule this workload on the other machines. So all I'll do here is say Ctl Create -f jobs, and this is just going to be a load test job, okay? So what will happen is the job will be accepted. I'm just pulling down the exact same container instance, but overriding the command just to run the Redis benchmarking tool that will load up my database. And now, what you can also do in Kubernetes without logging into servers, I can get a little bit of data about what's going on. So I can say kubectl logs, right? So we see that this thing is actually putting things out. Uh-oh, are things dying? Oh, I know why it's dying. Because I need to actually connect it to the database. This is what live demos are about, right? So kubectl delete jobs. What is this thing called? Redis Enterprise? Maybe load test? Let's do that. All right, so we'll delete the job. So what we actually need is the database information. So this isn't fully scripted. We need to actually grab the dynamic IP setup and port for this workload. So I'll come here and I'll take jobs and we'll configure it. Now, given all these APIs, we could totally automate this part too, but let's go ahead and stick it in there and try this again. All right, so we'll say kubectl create -f jobs. So at this point, we kick off another job. It seems to be running. kubectl logs -f to follow. Oh, so we see the benchmarking tool running. So if this thing is actually working, it should be flooding my database with keys. So many keys that it should overflow RAM and end up in flash storage. So the next thing we need to do is see if that's the case. So we're going to ask for our stats again to see if we've met that goal, because it's kind of making fun of me last time here. All right, so let's run it. Get the database stats.
The test database is using 1024.04 megs of RAM, 1670.65 megs of memory, and 646.61 megs of flash. Looks like your dataset no longer fits in RAM. And I did not have to evict anything. I gotta say, Redis on Flash is pretty dope.
And with that, I'd like to end the presentation. Thank you.